Okay, so to allow better concurrency and better performance while um reading DB states or updating DB states, DB systems will allow interleaving of operations across different transactions. Uh, yeah, for better performance. Okay, but when there are conflicting operations, it will cause issues. Conflicting operation is when many transactions try to act on the same resource and one of them is a read operation. So let's consider an example. Like there is a transaction T1, it does read A, and then transaction T2 does read A and then write A. So until read A in T2, there is no conflicting operation. But when it does write A, there is like yeah, conflicting act on the resource A. So DB systems will keep track of these conflicts using dependency edges. So here the conflict started in T1. So there will be a dependency edge from T1 to T2. Okay. Now the T1 transaction wants to read A again. So yeah, now there is a second dependency edge here from T2 to T1 because in T2 write A happened. Now T1 wants to read A again. So it will cause a dependency edge from T2 to T1. So there is a cyclic dependency here. We want to prevent cyclic dependencies. And we also want to prevent anomalies. So here there is a cyclic dependency and it also goes a bad state because if it would there was no interleaving allowed, then T1 would have operated like it does read A and then does something in its function and then it does read A again. So it would not have read the newer value, but because of interleaving it read the newer value written by A. So yeah, okay, so this caused an unrepeatable read. Now let's consider a second example where T1 does read A and write A, T2 does read A and write A. So there is a dependency edge like T1 does read A and T2 does write A. So read to write, this is a conflicting operation on A. So dependency edge from T1 to T2 because yeah, like it occurred first in T1. Now for the write A of T1 and read A of T2, there is also dependency edge from T1 to T2. So here the dependency like it is not cyclic dependency, there is just dependency edge, but it is acyclic. Okay, but yeah, like it can happen that the transaction one later rolls back. So it will cause transaction T2 to does a dirty read because T1 has not updated the value. Uh, it later rolled back, but T2 operated in a way that it read the newer value and then it updated state again using that value which was not correct. Like if it would have occurred serially, then it will happen that read a write a in transaction 1 and then even if the state was updated, then only T2 will read it. Okay. And yeah, so let's see one more example of lost updates. So like let's say T1 does write A, T2 does write A, and T2 also does write B, and then yeah, T2 sorry, T1 does write A, T2 does write A, write B, and like T1 again does write B. So whatever T2 wrote for B got overwritten by the T1's write B later. Okay. So yeah, this goes lost updates uh, for like both of them because T2 also wrote T1's A resource. Okay, so one more example for this is like let's say two persons are sharing bank uh, account and they um like two concurrent requests came for it. Um, read happened, like read A, and then write A. So, but because of interleaving, it may happen that read A happens from transaction one, and then read A happens from transaction one, and yeah, then they will both write. So now a transaction one will do write a, and now transaction 2 will do write a. But yeah, this again caused lost updates. So this is like also, this also created a bad state, like wrong state, uh, because it shouldn't have happened this way. uh, Transaction, it should have happened like transaction 1 first reads a, then writes a, then yeah, like transaction 1, after its completion, T2 will read a and then write a again. Because it could be like the write was, maybe they wanted to withdraw some amount, so initially it was 100, so a does 25 withdraw. So now B also wants to withdraw 25. So if both of the reads happened earlier, then they will both only does 25 withdraw, and the amount remaining is like 75. But it should have been 50. So yeah, this is wrong. So to prevent such things, like these anomalies and the cycles, we use looking mechanisms. Okay, although it is not like that DB systems will implement purely looking mechanisms, they can use some variations of it, like uh, I mean, they allow this, but I guess PostgreSQL uses MVVC. I don't really know how that actually works. I have only yeah, looked into looking. So looking, it will happen that for the 2PL, 2PL is like it allows conflict serializability, um, as in like uh, okay, yeah, like 2PL only allows a growth phase first, that in its growth phase it will only acquire looks, and then after any look is released on any resource, it cannot reacquire any new looks again. So if 2PL was like DB systems default for this example, like for this transaction, bank transaction example. So here what will happen is that all the DB systems don't know, like they can't foresee all of the operations in a transaction. So they acquire looks like in a growing manner, and then release looks in a shrinking manner. So for this example, it will happen that uh, the even with interleaving, it 2PL will prevent this bad state. Um, and also in this example, there was a cycle, uh, because T1 depends on like first read A happened then in T1, and then read A happened in T2. So and then write A happened in T2. Okay, so read or write, there is T1 to T2 dependency, and then T1 will again do write. So write A in T2 and write A in T1, T2 to T1 cyclic dependency. So 2PL's rule is that 2PL will uh, prevent any kind of such cyclic dependencies. Like its dependency graph will always be acyclic, and it also states that once it starts releasing, once any transaction starts to release locks, it cannot acquire any new locks again on any resource. Okay, so, yeah, here, even if interleaving is allowed, what will 2PL do is, let's say T1 does read A and then T2 does read A. Okay, so yeah, but now, like, this was a shared look. So uh, T1 shared look is like it can be acquired by two transactions at once, read look. Okay, now T2 will acquire an exclusive look because it needs to write in. Okay, so when it acquires an exclusive look, so for exclusive look, any other transaction shouldn't have the same look on the same resource. So now T1 will release its look, so T2 acquires the right look. So yeah, T2 does, uh, if T1 has released its look, that means its shrink phase has started. Okay, so now T2 upgraded its look from read look to write look. Okay, so it is in growing phase, and now it does the update, but now T1 is like it wants to write A as well. But for that to happen, now T1 needs to acquire look again, but T1's shrinking phase has already began, so it cannot acquire new looks. So if for this 2PL was enforced by DB system, so it will happen that it will maybe abort the transaction, and then it will restart it for T1. Okay, so then T1 will do a read again and then do write. So 2PL prevents this. Okay, but pure 2PL